Hello students, I'm Nilanjana Sanyal. Welcome you all to my channel NS Online Math Classes. Our today's topic is solving cubic inequalities graphically. This is part 2. We have already had one video session on the same topic. Over there the term containing x to the power of 3 in the cubic expression contained a plus sign. It was a positive term. And in this session, it will be a negative term. The term containing x to the power of 3 will be having a negative sign in front. So it will be a negative term. And apart from that, there will be other differences as well. And we are seeing over here, it is written with an isolated point. What do we mean by this part? With an isolated point, we have to know about this also. And we will be knowing about this during our session. Okay, so without any further delay, let us start with our today's session. First of all, let us look at the question given. Solve negative x. So this is the leading negative sign we are having. Okay, x plus 2 times x minus 2 raised to the power of 2. So this linear factor is getting raised to the power of 2 greater than or equal to 0. So now coming to the rules. Factorize the given cubic expression if not already factorized. So I have taken a factorized cubic expression because I did not want to spend more time on the factorization process. But you will definitely not be getting a factorized expression every time. So you should be knowing how to factorize a cubic expression or a cubic polynomial. And in case you have any difficulty, any confusion regarding factoring cubic polynomials, you may watch my videos on factorization of cubic polynomials. Okay? So since the expression has already been factorized, we do not have to factorize it again, obviously. We come to rule number 2. Find the x-intercepts or the zeros or the critical values of the given expression. So what are they? If you graph this cubic expression, the points where the graph will be crossing the x-axis or meeting the x-axis, the x-coordinates of those points, obviously the y-coordinates will be equal to 0 because it is the x-axis. The x-coordinates of those points will be giving us the x-intercepts or the zeros or the critical values. Okay? And how do we get them without graphing the expression? We equate each of these factors to 0 and get the values of x. So equating x plus 2 to 0, we get the x value as negative 2. So this is one of the x-intercepts. The corresponding point will be negative 2, 0. And from this x minus 2 equal to 0, we get the x value as positive 2. And the corresponding point will be 2, 0. So these two are the two x-intercepts or zeros, negative 2 and positive 2. Okay. Now coming to rule number 3. Sketch the graph of the cubic expression. It should start from the top right corner if the term containing x to the power of 3 is positive. Else it starts from the top left. Now, in order to get x to the power of 3, this is a linear factor, x plus 2. So the x to the power of 2 term should be coming from x minus 2 to the power of 2. We will be getting the term containing x to the power of 2 from this part, which when multiplied with x will be giving us x to the power of 3. And because of this leading negative sign, the term will be negative x to the power of 3. So it will be starting from the top left. Now we come to the xy axis and the two x-intercepts are these two, negative 2 and positive 2. And the graph will be starting from top left. So this is the shape. And you see over here for negative 2, the graph is crossing the x-axis, but for when the graph is coming to this point positive 2, it is not crossing the x-axis, but it is just meeting the x-axis or touching the x-axis and coming back to the same region. It is not crossing the x-axis. That is because this factor x minus 2 is getting raised to the power of 2. When a linear factor gets raised to the power of 2 or 4, I'm not going into the higher power details. Just remember, if it is just a linear factor raised to the power of 1, that is a simple 1x plus 2 or anything raised to the power of 1, the graph will be crossing the x-axis at that point. And if a linear factor is getting raised to the power of 2, then the graph will not be crossing the x-axis, but it will rather be touching the x-axis at that point. I'm not going into the higher powers. Okay, I'm just dealing with 1 and 2, the powers, as it can be either a 1 or a 2. Okay, so that is the difference. Over here, the graph is crossing at the point negative 2, crossing the x-axis, but the graph is touching the x-axis or meeting the x-axis at the point x equals positive 2. Okay, and now rule number 4. Select the region or regions below the x-axis for less than sign and above the x-axis for greater than sign as the answer, and include the zeros or the x-intercepts for equal to sign. If the equality sign is also included in the given question, then you include the zeros in the answer, or else if for less than sign, you have to include the region or regions below the x-axis, and for the greater than sign, you have to include the region or regions above the x-axis. Okay, now in this case, it is greater than or equal to 0, so we have to include the x-intercepts. Along with that, these 2 points, what will be the region or regions that we have to take? Since it is greater than 0, we have to take the regions which lie above the x-axis. So from this graph, we are seeing this is the only region which is lying above the x-axis. So what will be the x values for this part? It will be obviously x less than negative 2 for this part. I'm not taking this negative 2. For this part above the x-axis, x values will be less than negative 2. So we have to take all values of x that are less than negative 2 in the solution set of x. And because of this equal to sign, we have to include the 2 x-intercepts as well. So how do we write the answer? Let us look at the answer. Therefore, x is less than or equal to negative 2. I have to include this negative 2 as well. So I have written x is less than or equal to negative 2, or x equal to positive 2, because I have to include these 2 x-intercepts. Okay, because of this equality sign in the given question. This is the writing of the answer or the solution set in an inequality form. But if you want to write the same answer using the interval notation, then how do you write it? And this is the isolated point, because over here you are not having any region. It is just a single point that we have to include in the solution set. This is known as the isolated point. Okay? And now coming to the interval notation form of the answer, or x belongs to, since you can include every value which are less than negative 2, you are moving towards negative infinity, but negative infinity is not any number, so you cannot include this negative infinity. Hence, we are having this parenthesis and up to negative 2. Negative 2 will be included within the solution set, so we are having the square bracket, or is denoted by this union sign in case of interval notation, or it is just this point x equals 2, but we have to write it in form of an interval. So 2 comma 2, we have to write it as 2 comma 2, and these two square brackets indicate that 2 is included within the solution set. You cannot just write 2 because you have to give the interval. So the interval is 2 comma 2. Okay. So students, this brings us to the end of this session. Please like, share and subscribe if you find this video helpful. Thank you for watching this video till the end. We meet again very soon. Till then, bye.